Alright guys, this is your third video. Number 17 is pretty messy on the answer key, so I'm just going to work this one out again. I will tell you though, you're not going to have a problem like number 17 because you're not going to have something in with the x here. We haven't been doing many of those. We did them back in unit 2, but we haven't had it in this unit. So I don't want to put that on the test, and I will not put that on the test. Okay? But this is what I did for the problem. So I started by taking what's underneath the radical, and I pulled out a 3. Okay, so that's what I was looking at. Pulled out a 3, and the reason why I did that, in order to identify the horizontal translation, the coefficient of x needs to be a 1. Okay, so all the other problems, we don't have a number there. The coefficient is a 1, and we're able to just use this other number as what is it, like what's happening to the problem left and right. Now because I don't have that in this problem, I pulled the 3 out, so now I can look at this number and say, alright, what's this doing left and right? And that's going to move it right 4/3. So it's going to move right 4/3, and then this number 3 out in front, typically we would say vertical stretch, but when it's inside with the x, we talk about horizontal change, right? That's why we said this was a horizontal change to the right by 4/3. Okay, so it's right 4/3, and then that 3, horizontal is always backwards. So that 3 is going to do a, normally I'd think a stretch, but this is going to compress it horizontally. So this is a compress horizontally, okay? Alright, now a compress horizontal is the same thing as a vertical stretch visually. The numbers won't match up, but it would look the same if you were to graph it on your calculator. So if you look at the answer key, I put or vertical stretch, okay? So I'll have that point, and then for my next point, I'm just plugging numbers in. So since this is at 4/3, I went over to 2, plugged a 2 in. 3 times 2 is 6. 6 minus 4 is 2. So this would be the square root of 4, or the square root of 2, and the square root of 2 is about 1.4. So that was my next point. All right, and then I just kept plugging in some points. So 3, if I plug that in, I would get 3 times 3, which is 9, and then 9 minus 4 is 9 minus 4 is 5, and the square root of 5 is 2.2. And I just kept going from there. I got another point. I'm going to move over to 1, 2, 3, 4, 5, 6, 7. 7 would be 4.1. 1, 2, 3, 4.1. Alright, so there's my graph. Now before I connect these points, this should be a dotted line. If you forget on the test, go ahead and erase it and then make it dotted. But if you have a pen, please just put dotted on the side so that I know. Alright, you can see that I've forgotten that a couple times and just put dotted since I'm working with the pen. At least do that, okay? Try not to forget, but put it if you do. Alright, less than, that would be below, so I'm shading everything below this line. Don't extend past the furthest to the left x value. Looking at the domain, if I take 3x minus 4 and I just say it has to be greater than or equal to 0, 3x is greater than or equal to 4, x is greater than or equal to 4/3. So that right there is the furthest left that it can go. Now the range would be weird on this problem because remember, anything in the shade is technically a range value. So they would be all real numbers because this function does keep going up, and since it's below, we shade below, it's also everything below it. On the test, I will not make you put domain and range for inequalities. These are inequalities, right? Not equations. Okay, so inequalities, you will not have to do domain or range. Now you will for the equations like the other page. Alright, so I have that sketched. Once again though, number 17, you're not going to have that one on the test. You're going to have one more like 18 or something out in front like what we've been doing all unit. Okay, number 18. So more of a traditional type problem. Look at the x. There's no coefficients, just a 1. So this one's shifting at right 5 and up 3. Boom, plot that first point. Okay, from there, I found some more points. I just plugged in a 6, and I knew that 6 minus 5 was 1. Square root of 1 is 1. 1 plus 3 is 4. Boom, plotted that point. Also, there's no vertical stretch because there's nothing out in front, so I know it's just going to go over 1 and up 1 from the starting point. And then I did want another point to make my graph accurate, and I plugged in a 9. 9 minus 5 is 4. Square root of 4 is 2. 2 plus 3 is 5. Boom, plot that point. This line should be solid because it does have the line underneath the symbol. So solid line, and then this one would be shaded below. All right, let's move on. Number 19. Okay, so new type of problem. Add the exponents when you multiply. I am multiplying, same base, so I'm taking these exponents and adding them, and I got negative 1/6. Okay, well I know that if I have a negative, I need to change its location. So the 2 stays in the top, but the x to the negative 1/6 moves to the bottom, and now it's positive 1/6. And that would look good, but we know that a fraction exponent is really a radical, and we can't have radicals in the bottom. So I need to get rid of the radical in the bottom. So I multiplied by an x to the 5/6. Now why 5/6? Well, 5/6 plus 1/6 is equal to 1, and that would mean I would no longer have a variable or a fraction exponent in the bottom. So that's the number I chose. I multiplied it to top and bottom to be consistent. So I've got 2x to the 5/6 over x. Number 20. Common mistake on number 20 is I'm sure someone forgot to multiply the exponent to the b. The b's exponent to 1, right? Power to a power we know to multiply. 3/4 times 1 is 3/4. 3/4 times 3/2 is 9/8. This problem we can stop there because we do not have a negative exponent and we don't have fraction exponents in the denominator. They're okay in the numerator. So that's it. Number 21, I started reducing. First thing I probably reduced was the 2's, 1 in top, 1 in bottom. Then x squared and x to the negative second, I crossed those out because that'd be x to the 0th, which is just 1. And then I crossed out this y to the negative second with 2 of the 3 y's from this one. So I still have a y, and that's where this one came into play. The order that I'm doing this, though, you can do it in a different order. This is just the approach I took. So I still had that y. Okay, so I put that there. I had the 4, so I put that there. And I haven't touched these things, so I put those down. And then from here, I said, oh, I can reduce out those y's. I did that, and I'm left with 4 over x to the 3rd. 22, I split this one into 2 problems. I'm looking at the just the integer underneath, so the 72. To the approach I like to take, remember there's multiple approaches. I'll explain the other approach in the next problem. But what I like to do is I'd like to find a perfect square, since this is just a square root, a perfect square that goes into 72. I know that 36 goes into it, and it's a perfect square. So I split it to 36 times 2. Square root of 36 is 6, so that's how I got that number out. The radical 2 stays. Then I looked at the variables. And for the variables, if I have a to the 3rd, I could write it as a squared times a. And the reason why I did that is because the square root of a squared is just a, right? So I can pull out an a from the a squared, and I'm still going to have this a left underneath and this b left underneath. Okay, so that was the approach I took. You don't have to do this step over here where you split it. You can just divide the exponent. So if the exponent's a 3 and you divide it by 2, then it would be 1 remainder 1. That's what 3 divided by 2 is. It'd be 1 remainder 1. So you can pull out 1, but the remainder 1 means you also have 1 underneath. Okay? All right, and then I put everything together, and that's how I got 6a from these two guys. I multiplied those, got 6a, and then I multiplied this and got 2ab. All right, moving on. 23. Now, I don't remember things to the power of 4. Square roots, I remember those. So for this, I did the other strategy. And the other strategy is I broke it down to its prime factorization. So for 86, I just started dividing. I divided by 2, saw 243, tried a 3, got an 81, just kept on going. And I found that it was 2 times 3 to the 5th. Okay, 2 times 3 to the 5th. Well, that's the same thing as 2 times 3 to the 4th times 3. Now, why would I write that? Well, if I have 3 to the 4th, I can take the 4th root of that and pull it out. So that's where this number came. I still have a 3 and a 2 left. 3 times 2 is 6. And then my variables, in order to pull something out, I'm going to have to at least have an exponent of a 4. I don't have that. I got m to the 3rd and n to the 1st. So they just stayed underneath. Okay? 25. This one's a square root problem. They're both square roots, so anything that's underneath can be multiplied together. That was my first step. A to the 2nd times a to the 3rd is a to the 5th. B to the 8th times b is b to the 9th. The negative 2 and the 5 made negative 10, and then this 5 just stayed underneath. From there, I started simplifying. This step to the right is unnecessary. Remember, you could just divide the exponents. I like to just break it up to where I can see what can be pulled out and what cannot. So a to the 5th is the same thing as a to the 4th times a. The square root of a to the 4th is a squared. So I pulled out my a squared. The square root of b to the 8th is b to the 4th. I'm left with this a right here is left underneath, this b is left underneath, this 5 is left underneath, and this negative 10 still out in front. All right. Number 25. So I did that first strategy. 48 is the same thing as 16 times 3. Square root of 16 is 4, so I pulled out that 4. 2 times 4 is 8. So this first term is 8 radical 3. The next term, 27 is 9 times 3. Square root of 9 is 3, so I pulled that out. 3 times negative 2 is negative 6. So that's how I got that. And then 432, it took me a minute to find the right one, but I found 144 went into it. And from there, I took the square root of 144 to get 12. Now, if you didn't find the highest number, like say, for instance, you found 16 went into it, and then you pulled out a 4. Well, hopefully you'll see that there's still some more that can be pulled out when you do that. So if you don't find the highest number, it's not the end of the world. You can still get the right answer. You just have to keep going. All right, so square root of 144 is 12. Pulled that out. And then from here, I did see that all of these were radical 3's. So you can put those together. 8 and negative 6 and negative 12 makes 10. That does not make positive 10 though, does it? That would be, let's see. That would be negative 18. That should be negative 10. I'm going to have to change that to a negative 10. Unless I had negative 10. Let me see what I have over here. Nope, I didn't. So negative 10 radical 3 is what it should be. Okay, there's your third page. I'll make one more for the last page. Thanks for watching.